Wonderful. The recording is beginning.
Right. I need to
Yeah.
share my screen, right?
Yeah. Yeah. Go ahead and share your screen.
Pull this up here. Let's see. Let's see this one.
There we go.
All right. Make that full screen. All right. Ready to go?
Yep. Go right ahead. You're all
Right.
good.
Hi, my name is Brandon Barclay, and I love data. I had to do that cheesy, cool intro of I love data. No, I really do, though. It's just been a passion of mine. And so I just want to share a few things about some of the data exploration that I've been doing. Here's my LinkedIn page. Everybody should have one. Everybody asks if you have one. And I also love my wife, and she's up top there. So if you ever need to buy a house, I'll plug that just because it's there. And this is me. I have made it into the Google Hall of Fame under application security and under the honorable mentions section. This is something I threw together to try to explain that how this is me running data out of my house, trying to scale responsibly, control everything from my laptop, save money, and looking at my bottom line, trying to determine what are the real benefits of running a home lab and running on-prem versus running in the cloud. And aside from runaway costs of being in the cloud, what are some of the things that you gain and what are some of the things you lose, and the various learning experiences and aspects I've had to overcome. So when you look at cloud native storage, there's all kinds of solutions. You've got Longhorn and OpenEVS, Ceph, Rook, just to name a few. So there's other systems too that I took a look at, and the reason why is because I had this idea in my head of a beautiful world where in a beautiful world you have data that comes in really fast, it gets stored, but then as that data is sitting, why do I need to have that data sit on expensive drives when it's not being used? And then how is it going to intelligently push that data from, for say, a pool that I can just throw a bunch of disks in and it will intelligently figure out, okay, these are solid states. I can use those to capture the data. And then these are some hard HDD spinning drives over here. These ones are somewhat fast and these ones are a little bit slower. So if I take this data, how can I get it from the solid states intelligently onto a storage array of random disks such as, 1 terabyte, 500 gig, and it doesn't matter the speed of the drives, and it doesn't matter what the capacity is. The computer figures out when that data comes in, where should I put it and where should I move it so that I can make room for fast storage coming in. But then I could buy a bunch of drives or all the drives that I have laying around, 4 terabyte, 3 terabyte, 2 terabyte, 158 gig. I can throw them in a JBOD or in a server, and they don't have to just not get used. Well, this problem is actually, maybe corporations don't have this problem, so there aren't a lot of people that are looking at this as a problem because they're saying, well, we're putting our data out on the cloud now, but the cloud it's a little bit pricey, and it gets a bit pricier when you're trying to do certain calculations and you have data ingress and data egress costs and IO costs, and all those things add up in a home lab. So when you're doing, like when I had the other day, I'll show you here in another slide, I had a runaway Redis that dumped a gig onto my solid state drive. Well, that could in the cloud would have cost me a lot of money in IOPS to move that terabyte into RAM and then down on. It would be an expensive mistake. So one of the things that I discovered aside from this that I was going to do is I was going to use the Unraid ISO and install that on my local equipment and then use that to control this system that I just showed you with the solid states. But I found out that that doesn't stripe. It only has parity. So I wasn't gaining any speed necessarily from having those solid states out in front because they weren't operating. They're operating as volumes, but they're not operating as RAIDs because they didn't want you to put the RAIDs in. And so one of the things that I wanted to do too is then because that didn't have any connection up to Kubernetes, but it did have VMs, I could install the VM on Unraid, link that into Kubernetes, and then have Kubernetes with Longhorn. Longhorn could grab onto that as a virtual machine, as an LVM, and then I could use that as a drive and have multiple deployments of Unraid to pull all that drive space into Kubernetes to be able to use it on distributed platforms. But that all went away very quickly because there were other issues where Unraid's VM systems just didn't seem to be up to what I needed them to be. So
Hey, Brandon,
yes.
I got a question on this. So how much of this was stuff you had to kind of get in there custom, or was this more of just install and go, and how simple was it to get to what you're talking about here, or how difficult?
So that's the thing is that's why I say down here at the bottom, yes, it has a GUI. I can do a lot from the command line, but I've always believed a good GUI lets you understand the system faster. And then you can go in and work on it and be like, okay, I get what they're doing. This is why. And so what I was looking at was systems like Unraid that seemed fairly easy to use, just like Proxmox is for a virtual environment. And so, yeah, what is it clicking? It literally identified every single one of my drives. I went in and selected all the drives I wanted. I picked the 3 cache drives I wanted. I picked the 2 parity drives. I had to do nothing in the terminal to get Unraid. But then when it came time to use the VMs, they wouldn't work. They wouldn't load. It didn't work out of the box. And I just thought, well, this isn't worth it for me. I mean, where with Unraid, I think it was like $159 a license, which isn't bad. Like I was willing to pay that for my, 5, 6 machines. I just wanted it to work and it didn't. And there were all sorts of, after I got past the GUI, after I got past the UI, I had to start jumping through hoops and I just wasn't ready for that. So I moved everything back onto Proxmox, which I'll show you. And this is just kind of the layout, which will make more sense. I don't want to get too caught up in diagrams, but they do have a GUI, which helps, but you still have to do some drive configuration, mounting, and stuff like that from your command line. And so there are systems like Rook and Ceph, and when you install those in Kubernetes, they'll go out and find your drives, mount them, format them, do all of that stuff, put them in a pool, and put them on Kubernetes for you if you want to give it that control. And Longhorn doesn't do striping. It's a straight file system. They don't do parity. They're just replicating. So I'll show you a case here where I ran into a problem with a system that was already distributed and how it didn't integrate well with Longhorn's default settings, because they want to take something that has one persistent volume and they want to take it and replicate it 3 times, which makes sense. It makes it highly available. It puts it on different nodes. If one node's solid states crash, it's replicated it onto a different node. So then you've got 2 or 3 copies of that. If your system can find the path of least resistance and it can pick that copy up and read from it instead of reading from another one. And so it just does it, but it has something like quorum. So it's making it so that it's before it lets it read, it's caught up. And so, yeah, so I get into a bit more of like actual showing you stuff, but there's always this stuff out in the front. And every time I watch these videos, I don't know about anybody else, but when I watch these videos, I always fast forward to this part where it's like, is this guy going to do something? And so that's what I'm going to do that now. So I'm going to show you, this is Proxmox. It's a VM, like a virtualized system. You can come in and create virtual machines. You can get these containers. They've got all kinds of templates of stuff you can install crazy fast in containers. And then it's really nice. It has cloning, so I can clone my VMs here. I can set up Ubuntu, and then once it's configured the way I want it, all I have to do is just do a clone, and it's like up pretty fast. And then I can link these machines and their resources together. There's all kinds of stuff I can do from this virtual environment. And so, and it has Ceph, so I can build Zfs pools. I can build ZFS drives from here. I can build from all these drives that it picks up automatically. I can build an LVM thin pool. So that's been a real benefit for Proxmox and using it. And it's an ISO. So literally you put it on a jump drive, stick it in your server, or you could do bare metal installs, however you're distributing an ISO, and it will fire up. It's got, you know, wake on land for certain servers. So it's open source. You can download it for free. So it's been great. Like and the UI, like I'm a big UI, like the UI has been just so easy to navigate. It's so clean. They kept it really simple. You've got in-terminal shelling, has some issues, but I think that's OpenVNC. It's not actually the Proxmox. So I'll go ahead and start here. So I'm going in to show you some of my VMs, and I'm going to show you that this is all connected. You've got, you know, multiple, you can see what's connected here, your storage, your memory, your CPU, and this is over all of the machines that I have running here in the background. And so I'm going to go in and create a Zfs pool with these solid states that I have sitting on this system. And I had an issue with one of them because I went in and listed it, and then I decided that I wanted to clear it off. And instead of going into LVM, before you didn't see this, I deleted it, but I did a make FS on it just to get rid of it. And then it took out all my LVM settings. So now I have to go in, reboot the machine, and I'll have to clean it out from, not from here. So I'll have to probably rate it, zero it, unrate it, and pass it back through again. That seems to be the way that I've read other people had problems with this. So what I just did there was I went in and deleted these LVMs, so that because they were LVMs before, LVM here, LVM thin pool, I went in and deleted those. And what I'm doing is I'm deleting those so then I can add those to a ZFS pool. And if you don't know what ZFS is, it's basically software RAID. So I can create a RAID pool that's running on, instead of running a hardware RAID, I can create a software RAID. And I have the hardware RAID to do this, but I don't, there's like Dell stuff that I have to implement to like watch my drives and watch the lights and watch all the stuff to make sure that if a drive goes out, and here literally I've got to clear that other one off so that I'll have a backup. With this, I would lose it, right? Because if it's RAID 5, I've got to have so many disks. But in this case, I'm going to create a software RAID 5, which RAID 0 is like RAID 5 for ZFS. But the cool thing about this is I can come back in here and add a drive. So I will be able to add a drive in the terminal. I haven't found out how to add it in here with the GUI yet, and I don't know if that's possible. Everything refers me to the terminal. So I'm going to add it. I got an error, but my drive still works. So I'm going to leave it at that. I didn't research the error yet. Now what I'm doing is I'm going in and I'm going to configure this drive that I've just created. I'm going to jump into my, so here's my drive. And I'm going to create that. I'm going to actually add that as a thin provision. So what I'm doing is I'm taking the ZFS and saying, don't fill this up for my one virtual machine. Let it ride for as much data for as many virtual machines as I want to add it. It won't lock it up to the disk space that I gave it. So I'm going to give this 3600 because it has 3.6 terabyte roughly, and I'll keep an eye on it. So what I'm doing then is I'm going to go into my terminal here, and I'm going to take this drive and I'm going to run this really long, crazy command. I'll pause that, you can see it here. This really long, crazy command right here, if anybody ever wants it to identify a drive, it gives you the drive ID, because in Ubuntu and some of these, I don't know, other Linux, it has to, I have to be able to tell fscab when this machine reboots, mount this drive, but don't mount it from like dev sdb or sda, because if those change, then it'll mount the wrong drive. And if you've ever done that, it causes late nights. So one of the things I found is that you run this and then you get this by ID, which then you can come into fstab, mount this volume as an ext format with the default 00. And then I'm going to save that, and I'm going to put a command in of mount. I'm going to first make a directory to match it, and then I'm going to put a mount in. And so this is where, let's see here, code page. Okay, so
Brandon,
yes.
could you make your screen a little bit bigger?
Maybe. Let me see
Right
here.
about it.
Which screen? Is it this one, this black one here? It's a
Yeah.
recording. Let me zoom in for you. 1 second. Like that?
Yeah.
Okay, just on this here, because it, yeah. Okay, so what I'm doing here is I'm going in and I'm going to format this drive first to make it so that it will mount as an ext format. And so once I've mounted that as an ext format and I run that mount, oops, I'm gonna have to go back out there. What I'm gonna do is I'm gonna go into Longhorn, which is installed inside of Kubernetes, and I have to tell these drives, which it automatically will schedule all of these drives from all these different nodes. So here what we are looking at is you have multiple nodes, like this is one server, and another server. And what they're doing is one of them is operating as like a server to bring the messages into and help distribute the messages in Kubernetes. And then you have these other ones, which are worker pods. They might be doing, you know, scraping, or they might be doing database work, or they might be doing Spark, you know, or whatever, Redis, handling all those different jobs inside of these, instead of having them handle it on your server, which isn't necessarily a good idea, because that can slow down your traffic. And so there's all this networking and trafficking going on inside of Kubernetes. And then only one aspect of this is disk space. And it's so hard to manage. I talked to the CEO of Talos, which is an awesome distribution. It's an ISO, you install it on a machine and you have Kubernetes up and running. It makes installing Kubernetes super easy. And so I talked to him and he said they took a big survey, and one of the #1 complaints that they had about Kubernetes was the difficulties of data storage. And so when you're looking at that and you think like a system like Longhorn makes it easy, because I can come in here, I can unschedule my main drives so that they don't fill up with data and then crash out my OS. But what's happening here is so I found a bug in here which crashed out my whole Kubernetes system like 2 days ago, literally. And what happened was I think I had set eviction as true on the node, and then I added a drive while I was trying to evict another drive, and I think that crashed out my etcd. And so recently I've taken my etcd and stored it on the cloud in MySQL and went with K3s, because I didn't want to be storing my etcd. I would just want to have it on something I understand, and that was MySQL. So I took my etcd store, and okay, so what I'm doing here is I'm disabling these and I'm evicting my drives. And the reason I'm doing that is because I don't want my drives to fill up, like I was mentioning before. And I don't know how much of this I left in here, so I'm going to fast forward, because you guys don't need to see me evicting a whole bunch of drives. So I'll get to the point where I start to add this other drive, which is really what we're kind of after here. So I need to add this storage, and I come back in here, and so I'm evicting that last drive, I think there. And what I want to do is I want to add the solid state ZFS and add another system in here. And so what it does is it literally, that disk mount that we made, that ZFS disk, I can come in here. This is actually not the ZFS one. This is actually one that is on another server, but it was called large drive. And I thought that I had cut that portion because I believe here I misspell. I put disk, and you can see that it just won't work. Like, it will say unschedulable because that drive didn't exist, right? And so then I realized that, okay, I spelled the drive wrong. So I'll go in and edit this, and I can't just edit that now, it's added it. So it wants me to actually go in and delete this. And this Longhorn was put out originally by Rancher, which Rancher makes managing Kubernetes really, really easy. There's all kinds of tools and stuff in Rancher that make it making Kubernetes bearable, in a sense, that if you don't understand all of the CLI and you can't do everything from the CLI, you can do a bunch of it from Rancher. So I realized that I made a mistake here. And so then this is when I realized, oh yeah, I can't just edit this. I've actually got to delete this first. So, and I had this thing where it's like, now I won't try to delete this and add a disk at the same time because of that bug. I always do like one operation at a time. So what I need to do is I need to add this drive here still. So I'm gonna add that. And by adding it, you'll see that it's automatically gonna register the size of the drive, and it will start to schedule it. So if I have jobs out there that are working right now and they need a place to store data, this is gonna pick it up, and it's going to start to push off data onto this drive, and you'll see that drive immediately start to fill up with data. And so what I'm doing here is I'm saying don't go over 10 gigs. So if you're up to 10, leave 10 gigs on the drive. That way you have a drive that has so much space, it doesn't crash it out, right? And so that drive isn't the same as the other one where we had like 3.6 terabytes. This is one on an HP RAID 6, but that's a hardware drive. I didn't use ZFS on that one. After I set up the RAID, I thought, oh, wait, I should have done that in ZFS, but I just left it because I needed to get my Kubernetes back up after it crashed. And so here I'm setting up this is that drive you saw before. I'm giving it a reserved 10 gigs. I don't want to evict it because I'm just adding it, right? And look, at automatically over here, it's automatically saying 3.5 terabyte, right? So it's giving me that much space automatically. I don't have any volumes created yet because I haven't launched anything. But if I look at my nodes, I can see that I have this total size space over here, where that's the amount of space that's available on each node. So I know those two worker nodes have 1.45 terabyte, and this worker node for main worker has 3.47 terabyte, which is really nice because that means that I can start to distribute workloads across two machines. And I know that if one machine goes down and I have a replica of that on the other machine from my stateful set, then I can go and my machines will still be highly available. They won't be out of commission. Here, I'm popping into an application called Lens. So if you ever have to work with Kubernetes, even if you have Rancher installed, Lens is really nice because while all of your other systems are booting, Lens will show you the status of everything that's happening. Plus, I personally really like I love it actually. I love the way that they've done their UI and their GUI. Everything is so fast and it's so easy to get to. And the way they've laid out their namespacing is just brilliant. The way that you can switch between namespaces and the way you can, but they don't have as much functionality for adding things, but they do for managing, which is nice. Another difficulty you'll find with Kubernetes is going and having to open up node ports to be able to access systems. They've got a system built in for that, where I go to services and I can click on it, it'll open a node port for me and show me my UI. So that's been a benefit. But back to persistent volumes. One of the things with persistent volumes here is I've installed Solr, which is a Lucene-based, different application, same platform as Elasticsearch, where they're operating on the Lucene database. And then they're using Zookeeper to manage distribution of data and the way that they're going and receiving data on a sharded system. So that's why you run Zookeeper along with stateful sets of Solr with Zookeeper, is because it needs to be able to manage the way that it's distributing and the way that it's accessing its sharded replicated sets. And that's a problem that I'll show you with, even with Ceph, when I ran Ceph and I had distributed sets or with the various persistent volumes. What you'll see, and I'll show you a diagram of that, is that it tends to lend itself to over replication because it doesn't recognize that this was a duplicated set. So where Zookeeper is taking and making multiple copies and distributing multiple copies of this and making sure that everything is kept in time. If you have a system like Ceph or Longhorn that is also going in and replicating that replicated set, then what you're doing is you're starting to stack this on top of this, on top of this, on top of this. And it doesn't make sense that it would replicate it in that fashion because those data sets are already the same. So there's no point of copying that I found that a replicated set onto another replicated set that's already on that drive. When the system is already doing it, that's why you distribute it. And so I got Solr up and running. I'm adding a little bit more RAM here, and that's done that quick. Happens that quick. And so what I'm doing is I'm going into this backend now, and I'm checking to see if these persistent volumes have mounted to Longhorn. And then I'm going in and checking to make sure that Longhorn didn't automatically set these up as replicated sets, because again, I don't want to stack this data. I don't want to put, when I tell it to replicate it 3 times and it writes it to this drive and it writes it to this drive and it writes it to this drive, but then Longhorn goes in and re-replicates that again, I have to go in and stop it. That was the thing I was like, wait a second, why is this taking up so much extra space, like 3 times the amount? And it is because when I installed this, I did tell it that I only wanted 1 replicate, and it's only doing 1 replicate, but for some reason, it had still set my replicate to 3. So when I installed this, I definitely told it 3 or 1, but it added that. So I'm going back in and I'm checking these to make sure that they're not replicated, and they're not. It's actually only showing me that it has 1. You can see here on the RAID Z drive, that Solr that I just installed went out, and as you can see here, that was my 1,000 gig provision. And what it did was it put it onto this drive, which we added here a minute ago, and it already went in and distributed this, or it didn't distribute it because I asked it not to replicate it, but it went in and found a spot for it and wrote onto that node this copy of a persisted volume without replicating it. So it didn't take and write all 3 of these onto this one node. It split them up over the different nodes. There is one issue, and that is that because I'm using a replicated volume and I only have 2 drives, it does need an extra place to write that extra copy. So in this case, I do have 2 of the same replicated copies on the same drive. But when I add a 3rd drive, I'll evict that, and I'll evict that copy and it will write it onto another drive where it doesn't exist. So that's kind of a nice thing, is it handles that automatically. So if it has a duplicated copy in there and I go in and delete it, it will find another drive to go write it to that doesn't have that copy. And so then I'm going basically in here again to check. I changed this to 1 earlier, or I'm going to change it to 1 here, and see then when I save it, I don't get any response from the system, but when I do save it, it actually will save, and it does come back as, when I refresh this, it does come back as 1. And I checked that. So maybe I just accidentally fast forwarded past that part, but this is cool because it's showing me the namespace that this persistent volume belongs to. So when if I did put this in Solr, when I installed it, it would tell me that that persistent volume that I've attached here belongs to a certain namespace. So that becomes handy when I want to say, I'm having this problem with a certain namespace and I need to come in here and figure out what's going on with my persistent volumes, why they're not attaching. Sometimes they'll move a pod and then they won't reattach, and I have to come back in here and manually reattach them. So this is a bug that happened with the data storage that I wanted to point out. And this is a problem where you have a pod like Redis, right? And you're pushing gigs of data to Redis. Like in this one case, I'm using 100, I've got 104 gigs. I push it up to Redis. Redis is running fine. For some reason, that machine doesn't like the 104 gig. And so it decides to evict the pod, and it kicks that pod out, and that pod decides to travel somewhere else. And so I made this funny little thing like to send over to try and get someone to respond in Slack to my help request. And so I thought maybe a little cartoon would do the job. And so I'm basically like, this pod is basically saying I got kicked out, but for some reason it doesn't remember this transfer when this drive gets attached and comes over here. But I'm wondering if maybe Redis moves on to a different pod, and then for some reason, what's happening is it's reading its data out of a slave drive instead of reading it back off of its reattached hard drive, because I've got 100 gigs still sitting in here, but now I've got 208 gigs. It's somehow written back onto here and thinks, oh no, I've got all this data. I need somewhere to put it again. And it's dumping all that data back onto this drive. And so in a matter of 3 days, I have this 2 terabyte solid state drive that I had to turn replication off on. So I'm evicting all of these 1 terabyte of my 2 terabyte solid state drives that I have on 3 different nodes. I'm evicting these 1 terabyte collections because Redis has gone into Longhorn and replicated this data onto these multiple drives, but it didn't stop, and it didn't read it back out again. It just kept piling it back up. So I had to stop Redis and move it back to Docker, where I know that it's controlled and this problem isn't happening. But it is something that I hope to figure out, because I really like this distributed. It has, it automatically spins up slaves. I can add more slaves if I want, just by clicking a button, literally, and it will just add another slave, add another slave. And then if I want to balance it between masters, I can do that. It's just really, really nice to be able to distribute my data with Redis like this. So, and then here's the other problem with Longhorn and the load balancing, is that I'm pushing this data into here, and this is what's happening with something. Let me zoom in that. This is something that's happening with, the Zookeeper, right? Is this helping this replication process? But then you're pushing this out across here into Longhorn, and then Longhorn is re-replicating it, right? Because it comes into the replica set, and that's pushing it onto the drive. So where I've got this all the same data, this ends up being all the same replicate on one drive. And so you have to go into Longhorn and tell it, do not replicate this persistent volume claim, because when you do, it's going to literally pile up. And if you're doing this in the cloud and you're running this in the cloud and you're piling up data on top of data that's the same data, that gets expensive. That gets expensive really fast. Luckily, in a home environment like I'm running here, I can weed out some of those mistakes and I didn't have to pay some crazy IO costs or data transfer costs or some of those things that creep up on you. So where am I using all of this data? Well, I've got different systems, one of which is on Mongo that is going to be getting pushed into this system instead with Solr, because Solr is so fast for reads and writes, and we've just had such good luck with it that I'm now taking this other system that I've built, and this isn't a plug or anything, it's just showing you that I have this system where I can literally hit any domain and I can find like thousands of links. This is one, Kylie Cosmetics. I'll show you something else I've built that's aside from this product. Nike, I hit Amazon. I did that for a client the other day. Somebody that wanted links on Amazon. And so anybody who wants to come use the system can. So, I mean, it's really actually them using it, not me. But, and then what this is doing is basically it's going out and finding all this data and it's putting it into Mongo, and then Mongo is aggregating it super slow. So with this distributed system, I can distribute all these workloads, have the shards go out and pull that back in and get that data, right? So one of the things that this does is it populates all these. This is a security tool. I originally built it because I was going to launch it into the security industry, because there's, when you can find parameters like this and you can break these parameters out into searches, you can find all kinds of vulnerabilities in systems based off URL data coming into their system. So that was this initial project that I built, was kind of more geared around helping security in a white hat environment, because that I just promote heavily in helping companies like plug holes in their systems. So this is a system called ecomfrog, where I figured out ways to house and get data and on companies. And so I've got like a couple 100,000 stores in here, and I have lots of data in Spark. So with this distributed system, I'll be able to use all of that RAM from those multiple machines. If I have to upload, a 400 gig set of data into RAM to be able to run it through Spark. And so with this system, one of the things that I really wanted to focus on, and that's where I brought on a search engineer and I brought on, a dev for using Laravel, PHP. And what we did was we've designed and built out search. So you can go into the system and you can type in something like, well, here, I'll show you. It'll get there in a second. But what it's going to let you do is it's going to let you type out any kind of a product or any kind of lipstick is the one that I asked the dev that did this video for me. Thanks, MD, for that. Really appreciate him making this video. But then what I've done here is we basically made it so I can go in and search any product. And this is going to go across 100,000 stores, like millions of products, and it's literally coming back in seconds. So it's scaling across this whole system, going out across all these sharded sets on all these different drives, and reading this data back and just bringing it into a search platform like this, which is really what this is all kind of initially built for. And I do have to admit, just from a personal, I did get a little bit carried away, and there were things that I was like, I want to install this, and I want to install this, and I can have this program. This is so awesome. And then that really, I got a bit carried away, I think. And so I had to kind of bring it back down to earth and really install just what we needed. And so now we're kind of at that point where we can come in here and search. And this is one of the only systems that online that is going to and you can go register on here for free. Like, I don't charge anything for it right now, but it does not have this search functionality yet. But basically, it's the only system I found online that does it down to the product variant. So with all this data that I've been collecting for I can't even tell you how long it's been, but I've been building this and doing the calculations and building all these systems, because it's one of the only systems online that really breaks down to the variant level. And what's super cool about this distributed model of data and being able to house it in these different nodes is that even if the other system can handle it all, if it realizes that it can handle that data distribution by going out across these other systems and pulling it in, it won't even bother to try to, it'll just have all the other systems kick in and bring, that's why you want those faster, hard drives, and why that data replicated makes sense. At first, we're like, we don't want to replicate this data. What's the point of that? Well, then we realize the point is that it can go pull a chunk from here and 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 a chunk from there because it has them. And so that's the purpose of the replicated data set, is making it so that you can go out and pick up these chunks. So in this case, like this is one of the only systems online that I know of that will break down sales volume on products across, and this is a small set here that we're using because it's on a dev site and we don't want to like load it up with millions of products. But so what's cool is that if you look at Solr and all these different systems, when you click this stuff, it's not happening. They didn't load this data onto the client's machine and it's filtering. This is hitting back to the server every time you do best match, anything, top selling, most product purchase, anything that you click on is hitting the system back again. So if you're using something like Mongo and it has to go and aggregate, which Mongo does not do a very good job of aggregating, and it says that online, I didn't make that up. But when you try to aggregate data, it just doesn't do it, like Lucene, for instance. And so when you hit this and you're asking all those drives to try and read you back this data, they can't, because it's trying to do all this aggregating and all that, and it doesn't, if you don't have like the shards and the systems that they've worked so nicely with, like Zookeeper, to help manage all that in this big process that's going on in the back end of all this stuff changing so fast, it makes it really difficult to do at speed, and everybody wants speed, right? And so this is a bad example of speed, but I mean, essentially we're changing the layout too. So that is probably more than really what's coming from Lucene and Solr, because that all tends to be, we found, if there's any bottleneck, it's usually hasn't been with Solr or Lucene. It's something that when we brought the data in and we viewed it. And so one of the things is that I have my guy show you. I went through this and I thought I cut out more because he does a lot of circling around, but he didn't talk through most of this. So I had to just I told him that I would do the talking. And so he's changing features here, showing us all the features and how they change. But then he changes the variant here, which jumps up our values. When we click on variant, we go from a total products, from literally, it's changing price here, but we go from what might be 300 products for sometimes like 3,000 or 4,000, because we're taking that product and instead of it just being a lipstick now, we're changing it to a variant level. Yeah, there we go. That's the example of 366 lipsticks goes to 766, because now we've broken it all out, which something that would be almost near impossible with Mongo. We found that with our other UNO system for breaking out application data on variant IDs of URLs. In this case, when we're breaking out these variants, it aggregates in seconds. It's insane. And so what it's doing here is it's literally saying, hey, we've got this, but then we've also got all of these variants, and it hits back in seconds. And without distributed data and distributed drives and being able to control all that, and this is all built in my house, like literally to my right here, I have a Dell, an HP, a Dell, and another Dell servers that are sitting in a big rack here. You might be able to hear them in the background, but I've set all of this up in a home lab because I have massive Spark files that literally cost me lots and lots of money to pull in and out of the cloud. And so I thought, I'm going to put this all in, build a cloud system in my house that can aggregate across all this data and bring me back these results of this product. And it's been tough. It's been really tough. It's not that easy to do, and there's a lot you learn. I was on a phone call with I showed some of this to the CEO of Wooly, and he wanted to have a phone conversation. So we have a phone conversation, and I've got one of these things by my desk. It's like, it's a little dirty, but you can pedal, when you're talking, you can sit and like bike or pedal. And so I'm sitting here and I'm pedaling on this thing, and the power supply to my server is right under my desk. And I'm pedaling on this thing, just going out. Yeah, and I go to show him the demo, and it crashed out when it came unplugged. And so that I learned a hard lesson about distributed systems because, well, sometimes when MySQL goes down and it doesn't have the proper setup, the InnoDB won't catch up, and it corrupts. So I spent 3 weeks literally becoming somewhat of an expert on MySQL database recovery, and one of the companies that has this software has a really hard time of getting good explanations for how to use that software, and they asked me to do a guest post. And so because I was able to get through, and for MySQL database recovery, their application, I went through weeks of trying to find anything that I could do to recover this, and I literally was able to recover my database in a couple of days with this software, and it was free. So that was nice. And so that's kind of the beautiful thing, but you cannot trust necessarily that everything that you're going to install and download and work with on Kubernetes is going to be safe in the cloud, or that it's going to be safe anywhere you put it, because there might be that underlying bug that you didn't account for. And I know everybody says, like, make sure you have proper backups, make sure you have proper backups. And that's always hard to do. And so there is some of that in Kubernetes, or there's various systems, like Valera, I think is the name of one of them. But some of the documentation is so hard to follow, even with the drives and even with these systems, the documentation. Is everybody still here? Okay, I just want to make sure. So the documentation is so hard to follow that any company that's doing or building one of these systems, I encourage them highly, like, build a GUI, because the entry point is so much easier when you've got great visuals. And there is one company that, and this is not at promotional or anything for them, but developing in Kubernetes is extremely difficult. And so there's this company called devspace.sh. And if you ever want to like come up with one of these applications or these systems, this guy has done a brilliant job. And he has done a brilliant job of explaining how his application works. I mean, and basically what he's doing is he's taking from your dev environment, he's piping into you build the Docker file, you push it up into Kubernetes, and it sits there and it syncs your files as you're working, and it pops open the window and it opens a port. So I can literally sit and develop on my application, and this thing is syncing it to my pod, which is almost impossible. Normally you have to build a big CI/CD where I take what's being built on my local and I'm pushing that up to my Kubernetes, and then it goes out and it goes to the CID and it pulls down all the GitHub, and it builds the image and it does all the deployment for a dev environment. And so like the dev has really no idea except for what's on his local machine, which is heating up really bad because he's got all this Kubernetes installed on his machine. And instead, this way he works from his regular IDE, and he's sitting there and he's programming, and everything is being sunk into the pod. He pulls open the page, and all of his changes are automatically right there without any up or down or anything. It just syncs. And so, the guy's just got to be brilliant. I don't know. I've talked to him. I chat with him on Slack, but that's it. But everything he's doing here is just makes it so easy to like get into his application, which is mainly CLI driven versus the GUI, but he does have some GUI stuff. But you go to so many of these these systems and you get into them 10, I call it the 80-20 rule. You get in 80% and you're like, I've got this. And then you have this big, I gotcha, or something. And I don't know if that's like how they make their money as open source, is you're so far invested into it and you can't back out, or if it's that it just gets more complicated as you start using it. And so then that's when stuff starts to happen. That is my disclaimer with any of this stuff that's going on with if you're using this and you're pushing these systems up and you're using them to distribute your sharing is paused. Is anybody there?
Yeah, we're still here.
Oh, sweet. Okay, cool. Great. Okay, great. I feel like one of those 15-minute talks, that you gave to yourself. I mean, because not that I'm glad you guys are all listening. I'm just saying, like, I've done that before where I'm like, oh, they were offline for 15 minutes. Internet went down. Oh, shoot. So yeah, so that with this data distribution, I think it's important that you realize that how important these backups become, because these systems, they grow so fast. And they grow so fast and the data grows so fast. But the thing is you really have to keep an eye on the data and where, like, this is with my JBot. I turn my JBot on, I connect up. I think I've got like 30 terabytes in here or 40 terabytes. And to me, it doesn't seem like that much for big data. Like, it doesn't seem like some people's data sets and how much data they have. And so I sympathize in the sense that if you have like bigger data sets, and this doesn't have, none of my data is housed on here yet because I don't trust it 100%. So when I get to trust it a little bit more, I'm really going to start pushing a bunch of data into this. But right now, there's some stuff that this does really, really well, like ephemeral data set, where it's like if the pod dies, I don't care. And it does really good job of that. As
Hey,
far as
Brandon,
yes.
I think we're maybe not looking at the same screen. We still see the ecom frog with the lip gloss. Is that what you're looking at?
Not at all.
Okay, I kind of wondered.
Wait, has it been this way the whole time? No, I'm just kidding. Okay, yeah, no. Okay, so I'm gonna go back. I don't even know how to get back to that screen. I think it was this, right? Just the video. Okay.
Yeah.
So okay. Sorry, you guys are staring at that the whole time. I was talking about, can you see? Okay, yeah, I have to close that maybe, and then here we go. Okay, cool. Stop sharing my screen. I was basically just talking about, and I'll share this is my last point. And then I'll be willing and grateful to take anybody's questions. And you guys this has been great. You guys have been great audience. Thank you so much for listening in on this. I've had all these thoughts piled up and I really just wanted to share them with everybody. My son came in and I was like, buddy, I'm really busy. And he's like, oh, I just wanted to tell you something. I'm like, I'm really busy. He's like, what are you busy on? I'm like, I'm working on a presentation about data. And he's like, never mind. Like, he didn't want to hear it again. And so it's great. I'm glad that everybody else out there is willing to chime in and listen. Thank you so much for that. And so I'm willing to show you anything here that I can show you. I hope that I saw some screens pop up there and I'm like, oh, I hope that doesn't have my keys in it. So if it does, if anybody's editing this, can you please edit those out? I don't know if that happened. I try to get them all, but I try to pile as much into here and be as informative as I possibly can. But there's just a lot to this and a lot to understanding how our data is housed and how it's really being managed, and actually getting control of and being able to manage it in a responsible way. I think anybody who's doing that, it's a challenge on a daily basis of where's my data, how safe is my data, and what are my plans to manage these systems if they go down. And I just want to applaud anybody that has that responsibility on their shoulders, because I know how heavy of a weight that is. And it really is. So thanks everybody for listening. I'm open for questions.
Thanks, Brandon. Yeah, we can go ahead and if you want to unmute and ask them or not. I was kind of curious, what are you using to push the data actually? And you mentioned you collected it for quite some time. Do you just, what is the code or what are you out there doing collecting data?
Yeah, so I'm a big fan of Laravel, and I tried several other platforms and threading and Python and at the end of the day, like I'd spent so much time in PHP that I was like, I'm going to build this on PHP. So I built it in raw PHP at first. And then I was like, I need a better way to manage this. So I got into Laravel. And then with Laravel, it has really nice, organized, clean, almost operates like Java in a way. And so, in my opinion, but then it has a really great way of managing, because it doesn't handle like threading that well and certain things like that. It does a lot of like job-based management, like let's see, Horizon. I don't know. Let's see, 10.10.88 colon 801 Horizon. If you've never seen this type of dashboard before, it's like right now I have running on my system 3 million jobs, okay? And this is all housed in-house, and I have roughly, it'll take me 4 hours to get through 3 million jobs. And a job could be multiple, like this is basically a crawler, scrapers. Most of these jobs are doing that. Some other stuff, like I got a project for my wife down here doing some stuff with real estate. I've got, this is like if somebody hits UNU and they want to find links, this finds links. This goes out to all kinds of places. And basically this would be like one node, and we have this on multiple nodes, but we're still playing around with that in Kubernetes, trying to get that to where this will distribute out to all these nodes. And so I use something like Laravel Horizon because it helps me to really manage all of these jobs, and it keeps these workers in process. So right now I have it set at about 800. Sometimes I run it at about 2,000 processes, and that will keep literally, I have a PHP job and it will literally spin up 2,000 of that job and run them all sequentially, which is really handy. Like it runs really smooth, and it's fairly efficient on resources, but I run that on literally, that runs on this one VM here. And so this VM, you can see I've got 800 jobs currently running, and it's using like 68 gig of RAM, but that's some other stuff that's running in there as well. So that would also be my load balancer that is using proxy to scrape. And so there's all kinds of load balancing that's going. There is one load balancing system on here, and that's something that Kubernetes, when my Kubernetes cluster crashed, I was like sad, because that load balancing system, I can literally go into a deployment. So I had my load balancer on here, and I could literally go into my deployment like this with my load balancer and click here, and I can scale. I'm not going to do it on this one as an example. I'm not going to show because I don't want to scale that. But if I wanted to scale my load balancer, I can literally scale my load balancer here to like 10, and whatever ingress IP I'm using to get into my cluster, this is my cluster. Here are my workers and my server node. Whatever IP I'm using to get into this, and I've scaled out my deployment of, I can take any Docker image, dump it into here, create a pod, essentially, open up those ports, point an IP at it, and have it work. And so, and then once it's working, if it's an ephemeral job that's just doing jobs, I can spin it up and I can say, you know what, I want 5 of those, and it will scale it out to 5 workers right here. it will do it automatically, but if I want it to do it because I don't want it to get loaded up before it falls over, then before it fails over, I can set those resources. I can say, if this uses more than 25% of my CPU, open up, scale out to another pod, or open up another container, or go like open up to another node. And it will automatically scale that system out based off of the resources that I tell it to allocate towards that container that's processing that data, which is super handy because in this case, the load balancing system that I'm using on this is running a Docker. This is running Docker, and it's running this. But if this system literally like takes, I can't put 2,000 workers through this HA balancer because the HA proxy that it's running on is an older version that's single threaded. And so if you pop into something like HTOP, I'm going to stop sharing my screen for a second. I'm going to pop this open and then I'll show you what I'm talking about. But there's something on here that I just can't like advertise. So I'm just going to, I'll show you, but it's pretty cool because like you'll see the high CPU usage on it. Yeah, okay. So if you've ever used HTOP or ATOP, speaking of drives, ATOP, if you've never used ATOP in your terminal, it is a brilliant, brilliant platform to help you look at how much disk pressure, even if you're in the cloud, and you have a bottleneck and you have data coming in, and you don't know where the bottleneck is, and you're looking at your, I'll show my screen here, and you're looking at your system and you can't figure out for the life of you, why am I getting this bottleneck? And you're like, well, it's got to be the application developer's fault, or it has to be, that the machine needs more RAM. And if you really don't know, there is a good possibility, I've seen this time and time again, where it's the disk drives that are at 100% and they are unable you're running some small RAID of drives, right? And those drives are they're getting hammered, and so you can't. Yeah, so in here you can see this is probably, all these are running on 50 and 60%, and then there's just one that's running on 90%. That is most likely HA proxy. And so there's a newer version that I've worked with that I wanted to implement into this platform for proxy, but and I don't mean load balancing, I mean like proxy. So HA proxy, but that is actually going out and managing a proxy system. You can see it here at the top, but it's using the most CPU because it's single threaded. What's nice about Kubernetes is I can literally, like I was saying, I can go in and I can scale that pod and take it to where if that one pod is using 50%, I'll just scale it up. It'll flip that, turn that whole service on. And then what happens is Kubernetes puts a load balancer out in front of it. And so instead of now just hitting the one pod, it will start to relay the messages back and forth and take the pressure off of the other pod that was initially there. So like if I could do that in this distribution, I could take and say, hey, this is getting too much pressure, set up another proxy. So, another HA proxy, and then it would take that load off of that one, which is awesome. Like, it's awesome because we had that problem where the HA proxy was single threaded, and when it wasn't even this, it was HA proxy, and we were running HA proxy on a different machine, and we had one machine that was calling to HA, and HA, it was like all these were all 5% and 6%, and then that one thread on that CPU was high. But it's because we're talking about drive space. If you guys have never looked at ATOP, oh, I don't even have, that's embarrassing. I think that it should be on this machine, and it's not. I install it on all my machines now, but basically you can install it from apt. It's super easy, but it will give you, and I had a hard time with this because we couldn't figure out the bottleneck in our system. And it turned out that it was me thinking, why would I pay all that money for a solid state when I could get, this is back several months before I knew a lot of about drives and disk storage and disk space. I was like, why don't I just go buy a bunch of 3 terabyte solid state or 3 terabyte drives and we'll have all the disk space we need. But I wasn't accounting for drive pressure. And so I discovered ATOP, which solves a huge problem. And that is that when you give it a second, it, unlike some of the other systems, tells you, and it takes a little while, but you'll see it, it'll come up here and it'll start to report like SBA, busy 3%. And then what it will do is, none of these drives are being written to, so they're probably not that busy, but it will, but the system's busy, so I don't know if that's, or really this is just as busy as this one drive that's on this machine is not that busy because it's just not writing anything. But I have another machine that I could show you, and that has a RAID 5 solid states and a RAID 0, and that disk pressure on there is like 70 or 80% constantly, because it's literally writing that much data on those drives, that and reading that much data off those drives, and like just constantly. And so yeah, that's, does that answer your question? Did I?
Yeah, totally.
Yeah, it's pretty cool. If you guys want 2 more seconds, and I'll pop into that database and I'll show you on that server ATOP, and it's pretty cool, I think. But I geek out on this stuff, so and let's see, this one kid my niece is dating, he was going to college for this stuff, and I brought him in and showed him all this, and he didn't quit. So but he's like, should we be working on Thanksgiving? I said, this isn't work. This is fun. Did you ever have one of those passwords that you came up with and you thought it was a great idea, but for some reason it like contorted your hands weird, but you just never got around to changing it? And you always like mistype it a couple times on these Mac keyboards, where they came out with this butterfly design that was like, you really have to have a mechanical keyboard to stay sane. All right, let's see here, if that makes any sense. I hope. I'm going to show you this screen because this one has some disks on it that are busy, and I'll show you what I mean by drive throughput on a server where you have to take the disk and the storage into consideration, because it really does play a much bigger. I always thought CPU and RAM and throughput and latency on do I need a bigger a faster network interface card? Do I need a bigger whatever? But I never thought about drive space. And so it's like, whenever it came down to being this, I thought, oh, I never thought about this before. But if you take a look at this, do you see how this is a RAID 5 with 1 terabyte in a RAID 0. RAID 0. Total risk. I know it. I got to get better at this. But if you take a look at this, look at how busy that disk is. It's at 85% of its capacity. Okay, and it's pushing that like all the time. Okay, and that's where I really wanted this design, where I can push it onto this one and it picks it up, and then it stores it on other disks automatically, intelligently, without my assistance. And that's where I think AI will eventually solve it, where it's like just you throw a bunch of disks and JBOD, and it knows how to handle it and do whatever it does best. But I didn't find anything like that yet. And so, but yeah, if you look here, this is my disk pressure, and this is the drive like you saw on that other disk, or on the other server, which didn't explain it at all. This is my SQL ingesting what you saw in this Horizon dashboard. This is connected up. So this is running on a different server. And then I have another server here that is handling all of this. You probably didn't see my Horizon dashboard that I just switched back from. But basically all the stuff that's happening in Horizon is getting pushed into MySQL, and MySQL is ingesting down this data as quickly as it can. And that RAID 0, which is as fast as, I think is as fast as you can get with the solid state drives, this never handled this speed. This never handled this speed on HDD drives. And if I had this at a RAID 5, I think this would still get backed up. And so with this distributed model, I'm hoping that I can get some kind of MySQL. I'm going to go with a different type of a database. I thought it was going to be Mongo, but I don't think it's going to be Mongo now. But with this distributed database, I'm hoping when I do get brave enough to move this on to Kubernetes, I can release some of this disk pressure by distributing my database in some kind of a clustered database that shards off. What I really wanted was where it was doing all the shards on every single drive, on all of my Kubernetes nodes, across all of my Kubernetes nodes, and just intelligently figuring out where to store all my shards and make it so that if it crashed, I could still have all my shards, and then I could use any kind of drive again. Maybe there's a use case for that, but I don't know. So that's disk pressure right here, atop. And if you have never used it, and you're running into system load errors and stuff like that, check out your disk, because that was our biggest, out of all this stuff, that was our biggest bottleneck that we had to overcome to be able to take down and ingest this data so quickly when we didn't do it on the cloud. And so that's yeah, but yeah, that's
Cool.
I could go on all night, so someone's got to ask a question or stop me.
I'm gonna stop the recording because
Okay.
that part we can complete. So
Perfect.
yeah.